Hey everybody, this is Ben, and welcome back to another episode of the ComputerCraft Challenge, sort of, the ComputerCraft coding. I don't know what I'm going to call this now, really. I'm not doing the challenge aspect the same anymore, like I said. So, welcome back to another episode of ComputerCraft, I guess. So anyway, today, for you today, we're going to be looking at the code for this Turtle remote control server system. Now, I can't promise beautiful code, but I can promise code that works, and works in all of my tests. I have not had it fail as of yet, and there is a little bit of error checking and such network rebuilding built in. So it works well in my experience, and it certainly will work for the purposes I've intended here. So to start, let's look at the turtles. You can see they ping around every 30 seconds, sending their status back to the server. I found that is really the best way to have them getting updates. Now, the only reason they need to do that, and why I was talking about probably increasing that ping time a great deal, like to maybe 5 minutes or so, is that they really only need to be like just random pinging at random times in case somewhere along the route the route is broken. In the situation I had when I was working on the server, that everything else in the network would stay up, the turtles, the relay, the console, but the server would crash when I was debugging it. So then I'd have to restart the server, and unless I restarted everything, the server didn't have any idea of the status of anything else, because it just popped online and just sat there and said, okay, connect to me. I don't have it, writing out anything persistently to file or anything like that yet. So I decided that I inserted a command that the server tells everybody, hey, you lost your connection, because I was gone. But so that's why the turtles need to ping, is because the server will not have, let's go to turtle, sorry. The server will not have any idea of what their status is in the event that it restarts. So here we go, turtle client. You got my little packeting system up there because I can't really trust the data that is coming from the RedNet API because of the routing I have to do. So you may have, I believe I've covered most of this packeting system that I have. This message, I guess it's not even packets because it doesn't chop anything up. It's just a messaging system. I believe I covered that in my previous relay video, but here you have the ID of the computer a turtle it's going to, the ID that it originally came from, an array that contains the message, which I find that an array is the most useful way to send, a message with, I can have, specific, easy to sort out types and parameters and stuff like that. And then an array that is built as part of the routing called the route. So we start up, we're running. I just threw that in there in case I wanted to die. Initially, the parent is -1. It grabs my ID. The number of hops to the server is very high. The status starts out as idle, and the last good here, I don't remember if I inserted the last good, but the idea is that it will keep track of the last position in which it received a message, so that eventually I will set it up that when it does not receive a ping back from its previous parent, it will try to get a new one, and if it still doesn't get a response, then it will simply return to its last good transmission location in order to get a signal. And then here we have my send ser for send serialized. I got tired of typing this all out, and I ended up coming up with practically, like in my implementation anyway, almost a standalone routing function. That this is mostly what the relay consists of. So I'll go over that mostly in the relay code, but suffice to say, this is the function that sends messages. You got your to, your from, your message, which is an array, and your route array, which the route array is not super important because that is automatically built by this function. So we'll skip through that. Okay, so here is the first bit of code that's actually executing. We've got we just print out, we request the route, and then we broadcast. we broadcast, because we're going to nobody in particular, but that parameter still had to be there. My ID, we say the message is get route, and that goes out as a broadcast to everybody nearby. And anybody receiving a get route message will reply. And like I say, unless it's the server. I said that last episode. Server doesn't connect directly to anyone except for a relay or the console. So then we've got my ping status function here. This is what sends the status periodically, or whenever I tell it to, back to the server. So we're sending to server, which is a special case here. Since the server, I don't really need to know what ID the server has in order to send to it, and that's an essential part of this whole system. That we just know that the server, you just keep sending it up the tree to the parent until you hit the server. You don't need to know who the server is at all. Doesn't matter. Just send it up to the parent. Send it to your parent, that's the relay. Send it to your parent, in this case, that's the server. It wouldn't matter how many relays. Keep sending to the parent in a tree network, you'll eventually reach the root node. So, and then coming from my ID, and then here we have the message array again. So it's a status, the type of message is status, and that's so I can use that first element of the array, or table. I keep calling them arrays. They're like arrays from any other language, but Lua calls them tables. I'm going to keep saying arrays, I guess. So anyway, the first element of the array here, status, and then it sends status here, which is actually a variable containing the status, like here, I compare it and stuff. And then, of course, the routing information. So these two functions I will get to in a moment. This is the one that just pings. I guess I'll do this one. I'll talk about this one real quick. This one just pings every 30 seconds. If the parent ID is greater than -1, meaning we have a parent, then ping the status. If we don't have a parent, sending the messages is pointless. So every 30 seconds, it's gonna, as long as there's a parent, it'll ping status. But then I had to add this little bit here. While working, do sleep. Basically, I don't want this function to return while the turtle is working. And that was a bug that it took me a few minutes of thinking about to figure out the best way to deal with. And that's because I'm going to skip this real quick, because this is another function, rednet message, and we have not gotten anything that actually runs these yet until down here, the main loop for the turtle. While running, this is just always true, do, and here we have parallel processing. I did not think I would really need that as much as I did. It turned out to be pretty essential in order to have things work exactly the way I want it to. So it waits for any of the repeat status function right here, this one, or the rednet message function here. And I needed to have those process parallel because I can't have a sleep in the rednet message function. It'll drop messages. And likewise, I can't rely on a rednet event to be sending the status back, because, like I say, in the event of a disconnection where the server reboots or something like that, I need this turtle to continue, without it being rebooted, sending its status, every 30 seconds or so. So both of these had to run because sleep drops rednet messages and the pull event is blocking. So unless the turtle got something, this rednet message function will never move on. So I have it working where if either of they both run, when either of them completes, that's what this parallel wait for any does. When either of these completes, they're both the other, however many I could have in here. When any one of them completes, all the rest are killed. But in this case, the loop pops back over and we immediately again begin. Now, the problem with that is, well, let's go through this one real quick. So we get the pull event, rednet message, we parse out, we unserialize, we split off all of the elements of my, my messaging packet or whatever there to from, message and route, the 4 elements to from message route you're used to seeing up there. So then we can look at it. And I think Dan fixed this bug actually, but I was having some problems with backtalk to themselves through the modems. So if the sender up here, sender, okay, so if sender is my ID, then I just, comment and don't do anything. Discard that. So otherwise, if it's coming to my ID, then, okay, yeah, here we last good. That's my T API thing. If we're getting route info, then we check the route. If the second part of the route info is less than my current number of hops, then we have a new parent, and we go through do all that. That's why the number of hops is originally set to 9999. That there's not ever going to be something that has more hops than that in the network. I think Minecraft will have long crashed before you get that many relays going. So this is just a pretty easy... This is the number of hops that come back in the message, the second element, which you'll see in the relay. If that's less than my current number of hops, then that's my new parent. And in that way, I can get multiple messages. I can get messages from 2 different computers, in this case I have seen, where it will pick the one with the fewest number of hops. So it keeps the tree very, very tight, very short. If it's not route information, then the next thing, I don't even look at the message. If the parent ID is -1, if I don't have a parent, I can't handle any other messages. This is actually not so applicable in the turtle, but I may be having turtles act as relays in the future. I am not entirely sure on that one just yet, but I think they will at least have some relay ability. So this is kind of a relic of the relay. But basically, if I don't have a parent, I don't want to be handling messages. I need to have communication with the network before we do anything else. And then the only other thing the turtle actually has is this. If the first part of the message, the first element, says this is a command message, that's all the turtle actually handles to do most of its work here. So if it's a command message, then our status is working. Then we ping the status. We manually call that, so it immediately sends that status back to the server, saying we're working. And that would be, you can see on the console, I think you can still see it. Well, no, you can see it says idle. There were some before that said working, but they've scrolled off already. So then immediately sends it to the server. Then we do shell run, and this is the second part of the message here. The command, the program to run, and this element of the array is the parameters for that program. Pretty simple way to run. And this is blocking. The execution will not continue until that program returns. Once the program returns, however long that takes, whether it's, a second or, like when I'm telling the turtles to move 10 spaces, it takes 3-4 seconds, I think, or so. So then once that's done, then it comes back, status is idle, immediately send that back to the server. We're idle. And the server will handle that how it wants. And that is it. That is it for the turtle code. Boy, that took way longer than I thought to explain, but hopefully I laid some groundwork for the rest of these pieces. So I'll try to breeze over the relay here. This is very, very similar code to the turtle, actually, because I copied most of this to make the turtle one. So we've got the send serialized still here. Now, this is where this really comes into its own in the relay. That if we're not going to the server, pardon my tongue slip there. If we're not, the message it got, if the message that it's trying to send, is not being sent to the server, this 2 right here, 2, if 2 is not equal to server, which I said is the special case, then we're going to somewhere else, and 2 should be a number. So the 2 ID we're going to send to, we pull off of this route information. So we take off that last element of route, and that's the next relay or the computer that we need to send it to. And that's how the network kind of routes stuff. That route is automatically built when in this case, the turtle, when that route is automatically built when the turtle is sending back up to the server. So you can see here, if we're not going to the server. So otherwise, if we are going to the server, we take the route table and insert my ID on the end of that array. So on the way to the server, this route is automatically built. So then the server has that route. And then we just, send it to whatever we serialize that whole array so it can go over RedNet. So this one's very similar. We get a route, we broadcast, we do a get route, and in this case I pass another parameter server, which must be present in order for the server to respond to a get route message. It's just kind of a quick, easy way to force the server not to connect to turtles. Turtles don't send that. So then we've got our main loop here. This one doesn't need any parallelization. Let's say that 10 times fast. So this is just the basic, exact same code here. If sender my ID, ignore it. This is a new one that I added in. The network reset. If it receives a network reset message, that's so we set the parent ID back to -1, meaning we don't have a parent, and we do another broadcast saying get route potentially from the server. Essentially is what that means. So this is basically like reset, real quick. Reset your connection. So then if we get our route info packet, which is actually sent, this is one of the places that sends it right down here. This is the same. If parent ID is -1, this one really matters. If we don't have a parent, this relay is useless. So all we are doing is go ahead and requeue the event. The rednet event, just requeue that. This is not useful. It was not a reset message. It was not information about connection, my route info. So just idle around, hold on to that message. We're going to get a connection eventually. So, and then finally here, when the relay receives a get route message, we just reply to the sender with route info and the number of hops this one is away, and that is where it checks when it receives a message right over here. So yeah, that's a relay. That's nothing new. Otherwise, if it's not any of these special, essentially like network messages, then otherwise it just sends the message along, because all of the routing is taken care of in this function up here. As I said before, it checks if it's going to a computer or to the server and sends it along. It's automatically adding and reading from that route portion of the message. So I think that's pretty awesome. This is going to be a long episode. I cannot help that. So this is the server now we're looking at. Let me pop back over. We just talked about the relay up here. Turtles communicate to the relay. Relay communicates down here to the server, which is almost always doing something. So yeah, that's I can clean these messages up, I guess. Maybe I should do that a bit. So while we're in here, I'll see if I can clean up some of those messages real quick. So at the top, we start here, basic stuff. Okay, we have 3 tables, 3 arrays. Well, let's call them arrays. As I said, we have the status, we have the queue, and we have the route arrays. We have pretty much the same send serialized function here, except that I just took out all of the extra code with having to deal with sending to the server. Clearly, the server will not be sending itself a packet. That's, pretty obvious. Then I have a number of other functions happening here. This is to queue a command, and I, shorthand queue. He uses a command for a turtle ID, and it gets the commands and the parameters. So this is what's called anytime. Let's do this in the other direction to make this a little easier. So we broadcast, except the server broadcasts a network reset, which means everybody else, you should ask me for information on the route. That's what that is telling anything connected. Like, hey, I just booted up. Ask me for new route info, just in case. Then we run the loop. Same old stuff at the top here. Grab the message, split it out. Right here, in the route table, we get this from, which is the computer, or in this, it's always going to be the turtle so far, that the message originally came from. So we set the element associated with that turtle's ID. It's a very easy way to mess with arrays or tables, if you prefer, just by using the computer ID, because those are unique. Real easy. We set that to that route array. So this is saving the route back to that turtle. And anytime a message comes in, it is, like you can see, this is the first thing it does. Doesn't matter what happened. It sets the route for that turtle to whatever that current route was. So that keeps that, updated with the latest, so that when the turtles are pinging, they are updating their status and, without even trying, updating their route on the server. So as long as the message we got here is not nothing, we output some stuff on the terminal right here. This is a big one I want to get rid of. That's a lot of spam. And then if it's a get route message and the second part is server, which I said that's to prevent turtles from connecting directly, then we reply to that and we send the route info, and it's 0 hops. You have the best possible connection. If the message is command, that means this is a command for a turtle. So then we call qcommand right here. Qcommand, second part is turtle ID, third part is program, fourth part is parameters. So that's where qcommand up here, turtle ID, command, parameters, we call that. So let's see, we got status. Yeah, I don't need that anymore. So here we check the turtle status. If it equals idle, turtle's not doing anything, then we're sending the command, and then we just do a regular send serialized to the turtle, and then at the route packet we populate with the information from that troute array. Automatically takes care of routing it back to the turtle. Otherwise, right here, if the turtle is not idle, then really we right here, first of all, we check if this turtle is not, is new, then that element, the queue for that turtle ID is going to be nil. It's going to be nothing. So we need to make that an array or a table. That's unnecessarily confusing. Because they work just like arrays. Why did they call them tables? I don't know. Just a nicety, I guess. So if it's idle, we do this. If it's not idle, then table insert into this turtle's ID's queue in position 1, and then we just throw this array into that array, which is in that array. It's actually building up like a 3-dimensional array of command patterns. It's more than I expected, but an array is such a nice way to handle all this data that I can just pass it in and out easily. So that's the command. Here, when we get a command, excuse me, I'm trying to go too fast. When the server gets a command message, then it does that. It queues up the command for the turtle. So actually, even if the turtle is not even connected to the server, it can have a command queue. The server is very uncaring in how it handles this stuff, but that makes it pretty easy to handle. That, like, if you wanted to send something to a specific turtle, and then a while later you realize, hey, that turtle's not really doing anything. If you start it up, that turtle will immediately start getting commands from the server. I guess I should give that a try. But first, let's finish this up. If the server receives a message which is status, which is what that turtles are sending every 30 seconds, we call change status. And then, I want to print that one. So let's go back up to the change status right here. And comment out that one, get rid of these extra statements, make this a lot neater. So, change status, turtle ID, and the status it's changing to. That's all. So if the status is idle or the status is complete, which actually I think is redundant. Hold on. Yeah, I used to have it say complete and whatnot. It's not going to do that. I don't need that part anymore. I was simplifying the messaging, and it just, when it was done, I'll just set it to idle instead of saying, oh, I completed this job. Oh, it doesn't matter. So if the status is idle, then set the status to idle. And I got rid of this print. Then check the queue for that turtle ID. So anytime the turtle says it's idle, it's immediately going to be checking that turtle's command queue. Otherwise, down here, if the status is something besides idle, then just set that to the status. So I can, send whatever I want. I can, have crazy status messages just to be funny if I really wanted to do something like that. It doesn't, that's just, it's practically a Boolean. I could have made that busy. If busy is false, then do this. If is otherwise busy is true. It's just a little bit more informative that I'll be able to display that information on the console once I get that complete. So, continuing. Status is idle. We set our status to idle. Then we check the command queue, which is just down here for this turtle ID. So, if this is essentially saying we're looking at this route array. If the route for this turtle is not nil. So if there's a route, if there is not a route, we can't send that turtle a command. So never mind. I don't know how there could possibly not be a route. But, well, I guess that's the same case. If the turtle was not connected. No, I don't know. I don't know how this could possibly be called without a route, but it's still good to have that error checking in there. I think I managed it at some point, and that's why it's there. I'm not going to remove that one. And so if there is a route and the queue is not equal to nil, meaning there is a queue, at least that it exists, then next command equals table remove one command from that turtle's queue. Now this remove takes the last element off of that array or table. When we're inserting up here to queuing commands, we are inserting in the first position. So this is a first in, first out queue. It's not a stack or anything like that. So next command is the next one on the end of this queue array for that turtle ID. So then we check and see, make sure there is actually a command. If the next command is not nil, then we just go ahead and send it along like we would have originally. So it's just, all the queue is, it's just an array which holds a list of commands. And they will be run in the order they were received. So turtle, I mean, it's very, very dumb, I guess I would say. It's a very dumb system. There's no real, intelligence in deciding how to do things right now. It's very straightforward. There's going to be some probably more decision-making code having to be added in the future, and also I'm going to have to add systems not everything is going to depend on a queue. Some things the server is going to run automatically, like the mining, for example. I don't have to put together, I don't want to put together a huge command queue that I keep populating. I want to just have the server, whenever the turtle asks for more work, the server will just go, oh, you're supposed to be automatic. I'm just going to go ahead and figure out what you should do next, instead of looking to see, just randomly, blindly sending you something from the command queue. I guess the command queue should probably still be checked. Maybe not. No. You have to take the turtle out of automatic mode before it'll run off the command queue. So yeah, I'll have to do something like that. Have turtles have an automatic switch or something where instead of checking the command queue, the server will do some decision making. So that's all of those functions, and that's it for the server. I mean, it's all happening. That's what I wanted to split out the console, because this server, the loop runs as fast as it receives RedNet messages. There's nothing else that has to run. There's no chance the server's missing stuff. It's you're in and out of this server code as fast as it can execute. So the last piece is the console up here, which is an advanced computer for the reason only that I had one laying around originally. So yeah, you can see I don't really need to have all that either, I guess, in the in the console. So let's take a look at the console, and you're gonna see a lot of duplicated code in these things. Oh, except for this top part. This is simply a string split function, which I copied. Oh shoot, I already closed that tab. Apologies, I can't recall who it was on the ComputerCraft forums, but this is a don't reinvent the wheel type situation. I just needed any kind of string split function, and I liked the way this one seemed to work good. That it's longer than some others, but I understood it better. So anyway, that's just a simple string split. I'll talk about that briefly when I get to it. So the real start is here. Typical stuff. Control console. It's got the send serialized, except again, this one doesn't ever have to send anything anywhere besides to the server. And then the console here, because it requires both RedNet interaction and user input, I again had to parallelize down here. So we do a wait for any, but that's only if the parent ID. Why do I need? Wait a minute. Oh, hold on. Let me go back up. What? Read nil. Yes. Yes, I would. So, when it has a parent, when it's connected, then we do the parallel wait for any. Otherwise, we're only running the RedNet message function, because I don't want to be accepting user input, because there's nowhere for it to go. Again, that's kind of a connection thing. So we do, this is the same start. You open, you clear the terminal, blah, 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 request a route, broadcast, get route, server. This can connect directly to a server, though it does not have to. The console can be connected to any node in the network, any relay, and because it uses the same, routing information, the same message, like the packaging system here with the route and the send serialized, it can send stuff to the server, no problem. I just was realizing in my odd pause there, I'm not 100% sure how the server feels about sending back to it, because it doesn't right now. So that's future work again. So the console, the two parts that run in parallel are the user input and the RedNet message. The user input, we give ourselves the command prompt here, easy. We read in whatever the user enters. If the user didn't enter nothing, then here's where we split up that string on the spaces. I want words. That's the easiest way. And then here, the params, I realized, like, well, I don't want all of the parameters to be split into individual pieces. I want, first piece, which is the turtle ID, second piece, which is the command, and then I want all the rest. And I actually have not found anything that has an, elements 3 and following type notation for an array, or rather a table in Lua. So anyway, after I have those first two parameters, then I just get a substring of this temp in, which is the original string that was read in. I get the substring of that starting at the character which begins the length of the first parameter plus the length of the second parameter plus all of the spaces that will be between them. If you followed that, congratulations. Then this here, I'm going to change, that's too verbose. Print command sent. Actually, let's put that down there, so it's actually been sent when it tells me that. So then send serialized, simple thing, sending to server. We're sending a command for a turtle. That turtle's ID is part 1. That the command we're sending is part 2, and the parameters here are whatever was left. That's all the user input does right now. That's it. That's all we've got. This is going to grow massively as I continue to work on this, because this is going to have much more along the lines of a GUI interface, and probably have a lot of display on an external monitor and all kinds of stuff like that. That's a long way off, though. Don't get too excited. But hey, I'll get there. You know, I got here, didn't I? So then the other part that runs in parallel is the RedNet message, which should look extremely familiar. Oh, here's something extra. I'm gonna get rid of a lot of these debugs because this thing works swell. So we're popping in here. The message is not nil. If it's a network reset, broadcast my get route again. If it's route info, you know, get your route info, check the packet or check the hops, you know, update yourself if that's good, and that's it. I mean, the RedNet part, all that's for right now is just to connect to the network. There's no other commands, which, I mean, there will be when this thing is building a GUI. It'll be requesting and receiving a lot of information from the server about the status of various turtles and whatnot. So anyway, for right now, it's just straight up network connection stuff. This thing, anything, you know what? Any script that runs this function right here, I guess you've seen it enough now, you could type it out. Any script that runs this function will connect to this network. Honestly, I will almost certainly be putting this into an API now that I'm staring at it. So yeah, that's future work as well. Anyway, that's the console. I mean, really, the console's pretty one way. It's just taking the user input and passing that onto the server right now. I was literally trying to do the minimum to get the system in an operable state, and that's what I accomplished. So there you have it, my remote control turtle system with automatic building tree network. I'm extremely pleased with how this turned out. It's definitely the most complicated thing, as you have seen, that I have accomplished in ComputerCraft as of yet. And I will keep working on it. I will. But I make no promises as to the expediency of my videos. This is quite a lot of work, and on top of both my actual work and the weather getting rather nice out, I don't have that much free time to spend on here. But I will keep going, I promise. So thanks everybody for watching. I will be back when I am back with another episode of ComputerCraft. You might be surprised. Who knows? I'll never know what I'm gonna do in the next episode. I've freed myself from the bonds of the ComputerCraft challenge, and I have moved into a larger world of just staring at code. So I will see you all next time.